So my name's Wayne. I'm a software engineer at Over. We make a design app for your phone, and I'm here to speak to you about introducing Go to your organization. This talk is aimed at people who work in a team, so that could be your 9-to-5 job, could be an open source project, could also be a side project with some of your friends. The idea is that you have some code. Maybe you have an API running, maybe you've shipped a product or two, but that tech stack doesn't include Go yet. Obviously, you want to add Go to that tech stack, maybe for a specific reason. Maybe you've got some performance issues. Maybe you've just been mandated from your tech lead or your CTO to look into it. I've structured this talk around two major themes, the first being humans and the second being machines. I take this from the Go project itself, which aimed to solve scale for those two themes itself. So how do you have thousands of engineers working in the same code base, and how do you deploy that code to thousands of machines? So let's jump into the human aspects of this process. As Paul already mentioned, the Go project has a very good code of conduct. It's quite short and gets straight to the point, so I recommend everyone goes and reads it. Ultimately, I think as engineers, it's quite easy to get caught up in the programming languages and tools that we use. But actually, I think at the end of the day, the people that we work with are a lot more important than those tools. Again, the core values: be friendly and welcoming, patient, thoughtful, respectful, charitable, and avoid destructive behavior. A lot of technical goals that I'm going to speak about can actually be put under one of these points. For example, thoughtful could be expressed in writing good documentation or good example unit tests. Okay, so get involved in the community. I'd love to say that we should all submit PRs to some open source libraries, maybe contribute back to the language. Those things are great, but that's actually not what I'm talking about here. I think it's great to get a general idea of what's happening in the community. Where do people work? What kind of companies are using Go? Check out the survey results on the blog. This gives you a great idea of what's happening in the Go space. These are going to be the people that you're asking questions. You might be collaborating with them on some open source projects, and one day you could actually be hiring from this talent pool as well. So it's a good thing to get involved in the community. Use the power of the gopher. So Go has a fantastic mascot that I think everyone loves. I've never met a single person that doesn't love the gopher. And we actually have tons of artwork and cool little icons that we can use to bring Go into everyday language at our companies. So a quick example, this is our Slack channel at Over. I was bored one day, it was a public holiday in a few other countries, so I basically had the day off. So I just added all the gopher emoji. This has an interesting side effect of everyone in that Slack group now using the gopher to express how they're feeling that day. And it's actually lots of fun. I'd also recommend Ashley McNamara's gopher artwork. She's made them freely available on GitHub, and they are just it's impressive artwork. They make great avatars, great posters, maybe for events, but also stickers, of course. This is something that I've found quite interesting. When looking at any new tool, language, framework, whatever it is, tools are designed to solve a specific set of problems. They'll probably be very good at that. It doesn't mean they're very good at everything else. And I've had some breakthrough moments with engineers who haven't written Go before and didn't really want to, when I was just honest about what those strengths were and what the weaknesses were as well. And this really, it prevents conversations from devolving into my programming language is better than yours, and I'm just going to force you to do it my way. Because actually that's not the point here, and that's really not helpful or productive. Don't change your engineering culture. So this assumes that you know what your engineering culture is, firstly. So I recommend get to know the engineers in your team. How are they working? How do they like working? Does that mean they're using the terminal or they really enjoy IDEs? REMs versus query builders? What kind of frameworks? What cloud infrastructure do they prefer? And the goal here when introducing a new language to a tech stack is to not change all of those things at the same time. So go and do some research up front and find the Go equivalents for whatever they're doing so that there can be as little friction as possible, and it allows them to focus on learning the language and not learning new hotkeys for a different editor. This is also a good opportunity to actually change the way that people work, because just everyone might be using an ORM, that doesn't mean they're happy with it, right? So this could also be a good opportunity to change things. For me, I first got into Go because of the philosophy behind it, and kind of merging the two worlds of humans and machines here, I'd just like to say that Go is not just syntax. There's a lot more to it. We have the history, the specification, the language, the command, the runtime, the standard library, and a lot more, right? There's a very good talk by Steve Franciao, linked below there, where he talks about where Go was born, the environment it was in, what the problems that the people were dealing with that actually led to the birth of Go as a language. I think it's important to get an idea of Go at each of these levels to make sure that your expectations match the project's expectations, and you're not going to be running into friction every step of the way. So now let's get into machines. See, you got some containers and you're shipping them. It's great. Okay, with any creative work, which I do consider programming to be, I think the most important thing is to just start. You can stare at a blank canvas, you can read art history books. That's not going to help you be a good painter, right? So just start small. I'd suggest starting with some background jobs, internal tooling, maybe an experimental API, or some integration tests. Integration tests are a great one because lots of businesses don't have them, firstly, so no one's going to complain if you write some. And secondly, it's often better to write integration tests in a different language than your APIs or services were actually written in, because you can test some assumptions that that language or framework makes. But the important thing here is just to get into the mechanics of opening your laptop, writing Go code, shipping it somewhere, and actually achieving something. The one little thing I'd like to focus on is command line apps. Go is particularly good for writing command line tools because of the statically linked binaries, which means you compile a program into a single file, and that file can be copied up to a server, can be stored on Dropbox, and you can literally DM it to someone on Slack, which I've actually done, and it was amazing. So this is a little example of something I wrote at a company. These are JSON logs, which look horrible, right? But in production, these are fantastic because, so we log to Stackdriver, which means it understands how these log messages are formatted, gives you all this context that's lovely. But on your local machine, this is not great to look at. So inspired by the Fumt tool, I wrote a little command line app called logfumt, which just takes these JSON logs and attempts to make them look as similar as possible to Stackdriver. It just reduces that dissonance to try and get your logs to look the same everywhere. It's a little example of how you can write something in Go, maybe help the engineers in your business without actually changing any production services or messing with anything critical. If you are doing this, I'd highly suggest you check out Go Releaser. It's a release automation tool, which basically means you just tag your code in Git, and then it does the rest. So it creates GitHub releases for you. It'll write a nice change log with links to commits, and it'll compile your code into every single platform possible, zip all those binaries, and upload them to the release for you. This gives you such an unfair advantage because it means developers can come to your project, check out the latest release, and just download the binary that works for them. The other entry point here is to not write the code yourself, but use something that was written in Go. So Hugo is a stunning project. It's a static site generator, great for blogs and marketing pages, things like that. But where I've had so much success with this is that designers love it. Designers love that you can send them a single file, show them how to run it, and all of a sudden they have live reload, they've got a templating engine, they've got asset management, all these things, and it just makes it really fast for them. I don't know if any of you have had this experience where a designer in your company maybe wants to change a line of CSS on the website, and to do that, they need the static site generator you're using, which is maybe written in Ruby or Python. To get that, you need Homebrew. To get Homebrew, you need Ruby. To get Ruby, you need Xcode. So you sit there for about 2 hours just downloading things so they can change one line of CSS. The interesting thing is this can change the expectation on the engineers in your company, because now designers and non-engineers expect the software that you write to be very easy to transport around the company. And the standard just gets pushed a bit higher, and usually engineers will want to rise to that challenge. So once you have a few services, maybe running in Go, some command line apps, maybe a little experimental API, I'd suggest you start your own standard library. This comes from experience of seeing companies playing around with Go and then falling back to using whatever they were using before. Because at the end of the day, they had a year or 2 or 3 of business logic written in a different language, and it was just too convenient to go back and use that code. If you're using microservices, you're at a bit of an advantage because you can just consume those services. Often that isn't the case. But taking inspiration from Go's standard library, there are going to be lots of little functions that'll help you write Go day to day. So little things like maybe some error codes that you use in your API, some functions for instantiating the logger with formatting that's consistent to all your other services written in different languages. String helpers, I feel like every business has a weird way of formatting strings. HTTP middleware, and maybe passing user agents from the apps that consume an API. There are two main goals here. One is to do work for other people, essentially, so that people want to write Go in your organization because all of this is done for them and it's easy for them to use. The other one is you setting an example for writing good Go code within your organization. So this means you're doing a lot of what Paul said. You're writing documentation, you're writing unit tests, and it's also a good time to show people GoDoc so that they can actually explore this code and see what it does. Ultimately, try and prove something in the real world as soon as possible. I've crossed out production here because you might not be deploying an API, you might be doing something else, and that's great. But we have the advantage of Go being a very robust and performant programming language and runtime. So I found it actually best to get some work done, solve a problem, and then get out of the way and let Go speak for itself. You can't engineer those moments where people click and they kind of see how amazing Go can be, but I'll describe one of them that I had in a company I was working at. So these are some pods running in a Kubernetes cluster, and I had deployed some Go services and kind of was working on other things, and a different engineer was just checking out the resource consumption from our pods. And you'll notice that most of them are between a gig, 2 gigs of memory, and then right at the bottom you've got some pods using 10 to 40 megs of memory, right? So guess which ones were written in Go, and guess which pods were using the JVM, okay? It's pretty clear. This is one of those moments where you can talk as much as you want about how Go has a great garbage collector, it's performant, it's really good on memory consumption, but until you have a pod running in a production cluster serving real-world traffic to your users and still actually proving those points, that's when it actually clicks for a lot of people. My next point is that you should use linters and use all of the linters, right? So Golang CI lint, the last time I checked, has about 31 or 32 linters it can run. I think Go meta linter is lagging behind a little bit. But for me, there are two advantages here. One is you saving time in code review because you just don't have to check for a certain class of error, and it's great. You can focus on the business logic, the architectural problems, those kinds of things, and have really good discussions. The second is, for me, there's a kind of mechanical empathy to linters in that when people are new to a language, a linter gives them the freedom to discover those errors and learn from the linters on their own time, on their own machine, without other people kind of commenting and giving feedback, and it really helps you. And I think when so many engineers struggle maybe with anxiety or on code reviews, or they're juniors and they're just kind of scared, so they'd rather wait and then try and quickly get something into the master branch, this really helps us. It makes the whole process a lot more peaceful. Building on that, make your own linters. So this is surprisingly easy in Go. There are a lot of packages out there to help you do this. There's a lot of open source examples that we can learn from. And I'd just like to share one little example I had. I was working on a bunch of APIs, and we found that the casing of the JSON output was inconsistent. Some of it was snake case, some of it was camel case. Okay, we had a standards doc which said which case we should use, but that's such an easy thing to slip past a code review. So I found a linter that kind of did some stuff with JSON, forked it, and just started doing my own thing. So now we have a linter that checks the casing of your JSON struct tags, that they can't contain white space, and that they should basically all be there so that you don't get some kind of automatic name that you don't expect. And now we can add that to the Golang CI linter. It runs on every commit, and all of our APIs will be consistent regardless of the language or who writes them. Just like to give a shout out to the packages package, which gives you the tools for actually doing this. Custom build containers, starting to wrap it up now, but you have all these tools, these CLIs, these linters, and you want people to use them, right? So do the hard work and be the maintainer of custom build containers. It doesn't just apply to build containers. You could have containers for doing local development, maybe runtime containers that have extra security features in them or whatever it is. It's often as simple as a 3 or 4 line Docker file, building the container, pushing it up to a registry. That's the easy part. The difficult part is maintaining this over the months to follow. So that means security updates, bug fixes, adding more linters, changing the defaults, pushing those up with good release notes, and actually informing your team members of why they should update. Just some more useful links. All these slides will be up online. And wrapping up, again, my name's Wayne. I work at Over. You can find us at over.app. The Over Engineering Twitter handle was taken, so we're engineering Over. And you can find these slides at wayne.cloud. Thanks.